Yeah. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
Yes, sir. It's visible.
Yes, sir, Vijay.
Fine. Okay. So as part of today's demo, like PySpark, right, I'm going to cover the following topics, like what is Apache Spark? Why PySpark? Need for PySpark. See, most of them have, those who are updating with the Spark, right, they have some doubt, right, whether to go with Spark with Python or Spark with Scala, right? Like Spark Python. So difference between what Spark Python and Scala, right? Yes. Scala programming. PySpark features. A real life usage of PySpark, right? Real life usage of PySpark. PySpark job market. Yes. PySpark job market, right? Yes. So Apache Spark, why PySpark, need for PySpark, PySpark and PySpark features real-time message of PySpark job market, right? Yes. What is Apache Spark? Apache Spark. I can say it is a open source. It is a open source, right? Distributed, right? Cluster computing. Cluster computing in parallel process type. In parallel process type. With in-memory computing features, with in-memory computation, in-memory computation, distributed, parallel processed, cluster computed, in-memory computation, used for large-scale data processing, used for large-scale data processing. Used for large-scale data processing. Right, it's a open source distributed cluster computing in parallel process type with in-memory computation used for large-scale data processing. So you can see all this. You can see all this within the Hadoop environment also, right? Except in-memory computation. Because of this in-memory computation only, like that's got very high speed, right? So storage and processing both happening within the memory level. So everything stores within the memory, process within the memory. That's why very high speed, right? Right. So Apache Spark is a general engine for big data analysis, processing and computation, right? Yes. So you can say like why PySpark, right? Yes. So I can say like PySpark.
It's just one question.
So
Yes.
it's in memory on each node, or it's in memory on what is a where a
I can
request
say
is spawned.
it's a distributed RAM.
Ah, okay,
Distributed RAM, right? Yes.
okay, okay. And what about Hadoop? Is that is also distributed, but
But
it,
not in memory. There is no in-memory computation.
okay, okay, okay.
So here is simply saying, right, in Spark, the data object is divided into smaller parts stored across within the RAM, stored across multiple RAMs of multiple systems and are processed parallelly. It's going to store within the RAM level, memory level storage and memory level processing. Everything happens within the memory itself, but in Hadoop, it will be stored within the disks, right?
Okay.
So simply saying, right, Spark is 100 times faster than Hadoop. Means within the with memory level 100 times faster, disk level 10 times faster. So PySpark, Python API. It is PySpark is the Python API to use the Spark. PySpark is the Python API to use Spark. So Spark is a open source cluster computing system, I said, that used for big data solution, right? And PySpark is the lightning fast technology that is designed for fast computation, right? Fast technology that is designed for fast computation. So PySpark is one of the demanding tool today among the data engineers to work with bigger data sets. And it's used for generally why we PySpark used for just observe this. PySpark used for distributed SQL, distributed SQL for creating data pipelines. Data. See, Spark is a data flow language. Spark is a data flow language. Data flow means sequence collection of pipes, sequence collection of data operations. So the output of one will be given as input to the next. The output of one will be given as input to the next. The data flow. Creating data pipelines. Ingesting data into databases. Ingesting data into databases, right? For running machine learning algorithms. Running machine learning algorithms, right? Working with graphs or data streams. Graphs and data streams and many more, right? It's mostly used for running machine learning algorithms, graphs and data streams, ingesting data in database, creating data pipelines, and distributed SQL, right? Generally, you say, what is the need for PySpark? Need for PySpark means today, if you see, everywhere huge data is getting generated, means large amount of data is getting generated, everything through offline or through online, both, right? This data contains what the data contains, like hidden patterns, unknown corrections, market trends, customer preferences, right? All this and other useful business informations, right? So it is necessary for us to extract the valuable information from this kind of raw data, right? So we require a more efficient tool. We require a more efficient tool to perform different types of operations on this huge data or this big data, right? Yes. On this huge data or big data. There are various tools, right? There are various tools to perform multiple tasks. Already we have got many tools available on these huge data sets, but the tools are not that much of appealing, right? It is needed some scalable and flexible tools. We require some scalable and flexible tools, right? To crack this big data and gain benefit from it, right? So PySpark is such a kind, right? Where we can process, we can have a quick processing, right? So combination of Python and Spark, would be the very efficient way for the world of this big data. That's why Apache's Spark community came up with a tool called PySpark. It has come with a tool called Python API for using Spark. There is nothing but Python API for using Spark. So what is that need for PySpark? PySpark equal to Python plus Spark. Spark implemented with Python. So it's a combination of Python and Spark efficiently can deal with world of big data. So that's why, which is that Apache Spark community come with a tool called PySpark. Python API for using Spark.
So
And
it's an implementation of Spark in Python, or it's an API to use Spark?
see, Spark is an execution model. The execution model we are implementing using Python language. See, Spark can be, see, observe this. Spark can be coded with Spark can be implemented, or Spark can be coded with Scala. Spark can be with Scala language, you can. Python language. Java language, Spark for executing Spark can be coded with Java. And also using our language. So
basically the engine, the Spark engine, that is developed in Java, or how? So we have multiple flavors of Spark. Is that what it is? Or
no, 1 second. Spark by default built using Scala language.
okay.
Spark by default built using Scala language. Scala is the native language of Spark. In the year 2016, 17, 18, 19, right? There was a huge demand with Spark using Scala language. But if you see from last 2-3 years, right? Spark with Python has got great boom. Even job opportunities with Spark with Python has got more. Previously, like only Scala, 2016, 17, Spark with Scala only used to run, right? Spark with Scala programming. But you may ask why Python? Because Python has got a good, like huge, powerful libraries for, especially for machine learning libraries, for streaming, for other things, right? So for this, my Spark with Python implementation, right? So Spark execution model remains the same, but only the way you code, the way you are implementing differs, right? The same Spark APIs are not going to change. Spark related functionalities are not going to change. But the
No, my
program,
question is, let's say if we take Hibernate for an example, okay? So Hibernate is the implementation of some kind of JMS API, right? So JMS API is something again owned by the Java community, right? So there is JMS, there is Hibernate, there is what is it? Other implementations as well. So JMS spec is in Java, and also implementation is in Java. Okay, so Hibernate is in Java basically. Yeah, all the APIs and other stuff. Here, if you consider Spark, Spark is still the core engine or whatsoever that is part of Hadoop ecosystem or any ecosystem. It is in Java, Scala, Python, or
so it is an ecosystem. Spark, I can say it's an ecosystem of Hadoop, right?
okay.
Spark.
So it's
So,
written. It's basically written.
but in Hadoop, the total map reduce execution is going to happen. The model execution model is MR execution model. Map reduce execution model. Total the execution will be within this map reduce. It's an execution model, right? Execution engine. But Spark has got its Spark execution model is different as compared with Hadoop execution model. Okay.
Mhm.
Spark totally the architecture is different. And Spark, you may ask, right? Spark by default built by using what language means? Scala language. Most of these things will be using Scala language.
Okay.
Scala is the only language which is used for Spark. No other one using Scala, right? Scala is the language. Scala is a scalable language, extensible language. Scala is extensible language means Scala has taken the features from Java.
Okay.
But
So
what you won't see in Java is Java won't have this. You can Java has got only object oriented.
Hmm.
Java has got only object oriented features, right? But Scala can go with interactive mode. You can go like batch mode. You can go. It's like interactive shell. You can go batch mode. You can go means procedural oriented, object oriented, script based also you can go for Scala. But
so
Python,
if we
yes. See,
sorry if
for example, okay,
Mhm.
yeah, go ahead.
Yeah, if we let's say if I install Spark, okay, what is the runtime it needs? It needs Java or any other runtime?
If you go with Spark, so if you for Hadoop or Spark, right?
Uh-huh.
Java installation is mandatory.
Okay, okay.
For Hadoop or Spark, anything, right? Java is compulsory. Java installation. Without Java, you cannot install this Hadoop or Spark.
Okay, fine. Since it's dependent on Scala as well as I think Scala also needs Java
Scala is
runtime. So
yeah, Scala is nothing but scalable, extensible language, right?
mm,
Scalable language. It got extended from Java. Yes.
okay, got it.
but
Thanks.
but not that much of huge codings you see in Scala as compared with Java. Scala has got very less coding as compared with Java, and Python has got very much, like Python has got very less coding as compared with that. But Spark, mostly these two languages are preferred, Scala or Python. For implementing Spark, these two are mostly used. Even previously, if you go back like 2016, 17, 18, 19, 70% they used to 70% to 80% they used to use Scala. Only 20% they used to use Python. But now currently 60% of the industry going with Python, 40% they're going with Scala. Because Python has got, because of this modular programming, because of this modular modules, right? Which you won't see in Scala, right? So because of which Python usage has got more, even especially for this ML kind of machine learning. So we have got a separate library in Spark also, right? Spark ML lib, Spark ML lib, right? Spark machine learning library, where you can Spark also support this machine learning library. Spark became very powerful after that, after introducing this ML lib library, powerful library. If you heard, there was a technology called, people who got updated with Spark of the year 2016, 17, 18. Later, everyone, there was a talk and Spark is going away from the market, and the new technology called Flink, right, is going to dominate Spark, and Spark will be away from the market. Yes, Flink, both Spark and Flink are both Apache products. Both are introduced by Apache only. Both purpose is same. Both objective is same. But Flink has got some, but immediately what Spark came with powerful, Spark was little weaker with the data, with analytics, right? Data analytics was little weaker in the initial versions of Spark, one version, 1.3 version, right? It was weaker with the analytics. But from Spark 1.6 version onwards, like especially from Spark 2 version onwards, Spark became very powerful. It has introduced many powerful libraries, right? And again, with many powerful libraries, not only for that and machine learning ML lib, and not also for streaming and for graph algorithms, it has got many powerful libraries. Because of it, again, Spark has dominated Flink. Again, you won't see that, you are not seeing that Flink now. So that's why Spark version to version, there are many things introduced APS, like Spark APS. And that too, why we are choosing Python now? Because Python has got many advantages as compared with other programmings. But as of now in the industry, right, mostly Python and Scala are used. Very rarely we see Spark with Java. Like some companies, very few companies, they use Spark with Java, like Value Labs. They use like Spark with Java implementation, right? And OR language, they never use OR language, but it can be implemented by using OR language also. But among all this, Spark by default built using Scala language. Most of this APIs built by using Scala, right? Fine. So the combination of Python and Spark would be the very efficient way for the world of big data, right? But today, like job market for PySpark, we have got people who has got command in PySpark, right? We have got a huge packages, salary packages, right? As compared with other technologies, right? The same way you need to have command on this technology, right? Now, I'll just give some differences between Scala and Python. I cannot say both are equal, both are used equally in that industry, right? Okay, if you see this Python and Scala, right? Python versus
Hey Vijay. So,
yes,
but the like Spark implementation completely developed in a like only in Scala, not in Python, right?
yes.
Yeah.
Totally built. Spark was built even if when Spark was introduced into the market, right? Spark was
Yeah.
introduced in the year 2009, and as first it was open source in the year 2010, and it was donated to Apache Software Foundation in the year 2011. And many POCs were done, and the initial stages of Spark, right? Only Scala, Spark with Scala only. There were many implementations went with Spark with Scala. 2015, 16, 17, 18, right? Mostly the Spark with Scala, right? Especially from last 2, 3 years, right? Spark with Python, like PySpark, we are saying, right? Because of this ML, graph algorithms, other things, right? And we have got many models for Python. So Python, Spark with Python implementation also used a lot. Fine. And Python and Scala, right? Python, okay. Python, Scala, Python, dynamic. Is dynamic typed, I can say. Python is dynamic typed. Scala is static typed. Scala is static typed. Python has a huge community. Python has a huge community. Scala community is smaller. And Python contains, right? You see many things like Pandas module is available, NumPy module is available. Python contains powerful libraries. For ML, graph, streaming. But Scala has little. And one more advantage, I cannot say always Python. Scala has also got some advantage over Python, right? Yes. If you see, compared with Python and Java, even regular usage, right? Java and Python, which is faster among Python and Java? Java is faster as compared with Python. Python is interpreted line by line execution, right? So here also like Python is slower. Python is slower than Scala. And here, Scala is faster. Scala is faster than Python. Because even for Scala, we are using JVM, right? For Scala, JVM is used. In Python, interpretation, line by line execution. So both has got equal advantage, right? But the main advantage of Python, the coding will be less, simple syntaxes you can see, and easily understandable code, and many libraries and powerful libraries for ML, graph streaming for these things, right? And if you talk about the main features of PySpark, First thing is in-memory computation. In-memory computation. Both storage and processing. Both storage and processing happening within the memory level, right? Yes. Secondly, one more feature, right? Spark is lazy evaluated. Lazy evaluated and active evaluated means, what do you mean by active evaluated? Active evaluation, nothing but when declared, immediately executed. But lazy evaluated means even just like function, right? Function won't execute automatically until you make a function call. If you make a function call, then only that function gets executed, right? In the same manner, Spark is a data flow language. The data flow won't execute automatically. If you make some action, if you perform some action, then only the data flow gets executed from the root to the end, from the start to end. And it's a data flow means one flow output is the input to the next flow in the same way, right? Right. Lazy evaluated, right? Yes. Which one is better, lazy evaluated or active evaluated? Means lazy evaluated only. Means when required only, I'll perform action. So just like function, when required only, I'll make a call. Here also, when required only, I'll make an action, right? So that the entire flow gets executed. And PySpark has got some powerful fault tolerance model. Right? The fault tolerance model is a little different as compared with Hadoop here. So one thing, first you go, Spark is an execution model. It's for only for execute. Spark is not for any storage, right? Hadoop is meant for both storage and processing, but Spark is only for processing. So Spark is going to run on this Hadoop yarn. Spark is going to run within the Hadoop yarn cluster, right? Yes. So fine. Powerful fault tolerance. And one more thing is immutability. Immutable means changes, modifications not allowed for the data object. One more important feature of Spark, persistence feature. Persistence means the transformations can be reused. Reusing the transformations. Reusing the transformations, right? Transformation in Hadoop, the transformations can't be reused every time. We need to start from the beginning, but here transformations can be reused. Already the executed transformation output, you can use it again, no need to re-execute, right? Yes.
So what is transformation?
Reusing the transformation. Transformations and actions in Spark especially deals with two things: transformations and actions. Transformations, right? Like filter transformation, grouping transformations, Means if you perform any operation, performing any type of operation on data object, transforming as per the business logic, right? So if you perform any operation, right, if you're transforming the output, the output, whatever you are getting can be reused. Again, we no need to re-execute the same operation. If you execute for data flow is there, for example, data flow 1, flow 2, flow 3, flow 4. Flow 4 output directly I can reuse. Again, no need to execute again the flow 4 flows. If I have already executed flow 1, flow 2, flow 3, flow, see, observe here, this one. Okay. A is there. B, the flow is like this. A, B, C, D, the data flow. Data flow language. From D, it is going E, F, G, H. Means this is one data flow. This is one data flow. So first this data flow executed. First data flow executed. Again, to execute the second data flow, no need to execute from the beginning. Directly, this output can be used by the second flow. This second flow is there at flow 2. No need to execute this first 4 steps. Already the 4th step output it can take as an input. So I said this output will be input to this next one. This output will be the input to the next one. This output. So whenever the first flow is executed, already totally it has executed. From second time onwards, this flow to no need to execute from the starting. Already I can reuse this D output as input to this. Means directly my flow will start from here, small steps, right? So I decrease some steps, even though here I have taken a small, but if you say 100 steps are there, 100 steps. In the 70th step, if I want to reuse, means 70 steps are decreased, right? Right. But that is what this one need to be persisted. The one whose output is commonly used by many flows, this flow also using, another flow also using, nearly 5 flows are using this output. The one whose output is commonly used by multiple flows, that one you persist it. Persisting means make it available in the RAM so that many flows can reuse its output. Generally, we'll make some particular data objects to be available in the RAM itself, because its output can be used by many other flows. So if you persist it, it will be available. It is going to be available within the RAM so that the other flows will take its output as input. That is what persisting means, reusing the transport. We have got a lot of discussion on this persistence, different ways of persisting, and where you will be persisting. Is there any chance not only within the memory, within the disk also you can, memory and disk, right? In-memory computation, lazy evaluated, powerful fault tolerance, immutable, changes, modifications not allowed. Yes. So where exactly we use this Spark in real life usage, right? Real life usage. Many are the real life usage of PySpark. First, in most of these commercial sectors, right? Commercial sectors. In the commercial sector, right? Yes. We are using Apache Spark for real-time processing, right? We are using this Apache Spark real-time processing system. Batch processing, Hadoop performs batch processing. What is the difference between batch and real-time processing? So here, both in Hadoop, in Spark also we perform batch processing and real-time processing. Batch processing and real-time processing. some 1 lakh transactions happened. For example, today some 1 lakh transactions happened. At the end of the day, just you are just identifying that some 5 fraud transactions has happened. What is it? 5 fraud transactions has happened. About 1 lakh, in that 5 fraud transactions has happened. But real-time processing means whenever any fraud transaction happening immediately, right? Identifying that a fraud has happened, right? Real-time processing. Then and there, right? So even if you see in the commercial sectors, right, Spark real-time processing, especially like banks and financial fields, they are using Spark and mainly to retrieve the customer social media profiles, analyzing to gain useful insights to make the right decisions, right? Credit risk assessment, targeted ads, customer segmentations, and fraud detections, right? And secondly, in Spark in healthcare also, right? In healthcare. So just to analyze, Spark is used in analyzing the patient's records and what is his previous medical reports data, identifying which patient is likely to face this problem even after being discharged, right? Who is going to face the issues, right? Yes. And today, like Spark mostly used in the entertainment field, right? Entertainment industry, if you talk about this, you see like so entertainment is one of the largest sector which is growing towards this total online streaming, right? Online streams. So Spark performs like the streaming. Spark performs streaming, micro batching, streaming, even like the Spark streaming is available, right? Spark streaming or capturing live streams, live streaming data, right? And so if most of the entertainment industry is growing towards online streaming, if we talk about this popular platform, Netflix, using Apache Spark for real-time processing, right? So for personalized online movies, web series, right? So it is going, Spark is going to process nearly 450 billion events per day. 450 billion events per day, right? That are streamed over the server-side applications, right? Yes. Apart from this, even it has got within this e-commerce and trade. E-commerce and trade, like in e-commerce websites like Flipkart, Amazon, like Apache Spark is used for advertising, right? So in many other sites, like for enhanced customer experience and overall performance, right? Optimized overall performance, we use this. Even this tourism, right? It's Apache Spark is widely used to provide different types of advices. It is going to provide to millions of travelers, right? So here in Spark, we have got not only streaming, right? Not only streaming, we have got also, we can make a lot of querying also, like we have got a component like Spark SQL, right? It's a module in Spark which integrates with the relational processing, right? With Spark's functional programming, right? Combined, we can extract the data by using SQL query language. Like if you want to work with pure SQL query also, those kind of querying can be done in Spark. Yes. Fine. And as I said, right, PySpark has got very high speed processing, very high speed processing. And it said, so yes, Mallikarjun, right? Yes. So Spark integration, right? In Kafka. Kafka is one of the messaging service, right? It's a messaging kind of Kafka. Spark and Kafka integrations, where Kafka acts as both messaging and streaming, right? Kafka is there. Apache Kafka is there, where it can be used as both like messaging system and also like streaming system.
Sir, what are the differences between PySpark and Spark SQL? Is it only language different, or is it completely different?
So we have got, it's a component in Spark, right? Spark core, Spark SQL, Spark streaming, Spark MLD. Right? So even for making the data structured, making the data frames concepts, which is Spark SQL introducing, Spark SQL is introducing data frames concepts. Spark data frames. Spark data frames are different from Pandas data frames. Even those also can be used within this Spark environment, right? So making the data structures, making and organizing in the form of rows and columns. On that we can perform, we have got Spark providing many APIs are available. Using the Spark APIs directly, we can use that API functionality built-in function to perform the operations. Or still, if you want SQL kind of experience, right? Even we can do that by registering as temporary table, data frame to be registered as temp table, right? And we can perform pure SQL kind of querying, right? But in Spark core programming, there won't be any kind of tables, table structure. But in case of Spark SQL, there's we have got first a data frame to be created. Many data frame APIs will be available, working with different file formats.
Okay. So who are comfortable with Python will go to PySpark. Who are comfortable with SQL will go to Spark SQL.
No. Compulsory Spark SQL is for any Spark developer. Spark SQL is compulsory. Spark SQL is the main thing, right? The core part. Anyone who updates with Spark, compulsory Spark SQL required. Data frames.
Sir, hello.
Yes.
Sir, what is the difference between Azure Databricks and Spark?
So, okay, see here, 1 second. So here we have got cluster, right? It's a cluster computing, right? Spark can run where you can run Spark, right? Spark can run on. Spark run on Hadoop cluster and Hadoop Yarn cluster, AWS. So distributed clusters, Mesos. So some distributed Spark can run on many different environments, right? The cloud environment. In Hadoop Yarn, it's mostly used Spark, Hadoop Yarn. Now AWS it can run by maintaining clusters. Right. Different distributed clusters, right? Different distributed clusters. Right. Spark can be coded with multi-language support. Spark can run on different distributed executions. Right. So here I'm once again like Spark is an execution model. It has got its own execution model, right? It's meant mainly for parallel processing, for mainly used for huge data processing, right? Within quick time, quick results, and we can perform many analytics, right? It has got powerful libraries. It has got many APIs available, right? Especially data frame APIs, many data frame APIs, and machine learning libraries, graph algorithms, streamings. So the main thing what we see in Spark, is RDD. Resilient distributed analysis by Spark with airflow dynamics. All right, airflow is used for shared. Yes. RDD, resilient distributed data sets. RDD, right? Spark data objects. Spark data object, we call it as RDD. Spark data object is called as RTD, right? Okay, resilient distributed data sets we say. Resilient distributed data sets. So here, Spark data objects. RTD is subdivided into Spark data objects are called RTD. RTD is subdivided into partitions. RTD is subdivided into partitions. These partitions are distributed multiple RAMs, multiple worker nodes, and are processed parallelly, right? If RTD programming style, see RTD or Spark programming style is data flow. Data flow is a sequence collection of pipes. Pipes nothing but RTDs. At each pipe nothing but at each RTD. At each pipe, data flow is sequence collection of pipes at each RTD. At each RTD, we perform a data operation. Data operation like such as loading the data, filtering the data, transforming data, merging the data, sorting the data, etc. So here, Spark data objects are called RTDs. RTD is subdivided into partitions. At each pipe, we perform data process, loading, filtering, transforming data, merging data, sorting, etc. Right? Yes. So here, observe here. RTD1, R1. It is divided into multiple partitions stored across multiple RAMs of multiple slaves. The output of RTD1 is taken as input by R2. And R2 output is taken as input by R3. The data flow. RTD1, RTD2, RTD3.
So what is this R1 in the sense? Is that a data
RTD1.
packet or?
This is a data object. The data
So
object, on this data object, if you perform any data operation, if you perform any data operation on this R1,
Mhm.
the output whatever we get is also a Spark data object only, R2. On R1, think that you got some 10 lakh records. You perform some filtering or perform on R1 dot filter operation, right? Based on some condition. R1 is a data object. On that R1, you perform some filter operations. The output you get some 4 lakh records. Means R2 is storing what? 4 lakh records. on this R1, you perform some kind of transformation, filtering, grouping, aggregating, transforming, something you perform, the result, whatever you get is also a R2. So R2 equal to R1 dot filter. From this, whatever you are getting, the output is nothing but R2. R1 has got, but original R1 remains same. R1 will have 10 lakh records as usual. It's immutable. But R1 output you are taking, filter it, whatever output you get, store in R2. R2 has got 4 lakh records. Again, in R2, you perform some kind of any operation, data operation, right? The output you get as R3. Output is taken as input by R3. In this way, the flow continues. So this entire flow, if you perform action only, then it executes. Otherwise, it won't execute. So in Spark, we have got transformations, inbuilt transformations or actions. We don't need to perform inbuilt transformations available, inbuilt actions are there. So we have got mainly 3 types of transformations. And what are the different types of actions? One by one, we'll be discussing as part of this course, right? Fine. So just to go through this content, what we are going to discuss, right? So Spark features need for Spark comparison with other processing technologies, right? Spark session, Spark context, Spark parallel, repartitioning, broadcast variables, accumulators, operations on RTD, DAG, right? And RTD actions and different actions and transformations of and RTD computation, steps in RTD. What are the steps in RTD computation? RTD persistence options, RTD persistence and persistence options, persistence features. And the persistence within the memory, within the disk also you can do memory and disk only also we say. If memory is not available, you can persist in disk. If the data object is too big, then you cannot persist in memory. You can go for disk. PYSPARK core computation, right? Fault tolerance model, different ways of computing, increasing the number of partitions. So in Hadoop, we cannot control the parallel processing. In Spark, we can control the parallel processing. Right? In Hadoop, it depends upon that number of blocks, but here we can control the parallel processing. Right. Aggregation over structured data, increasing the number of partitions, creating Spark data objects from scale objects. Reduce by key is the important functionality. Reduce by key, group by key, count by key, count by value. Various groupings and aggregations, single, multiple, single grouping, multiple aggregations, multi-grouping, single aggregations. Difference between reduce by key, group by key, process of reduce and group. Yes. Various transformations, various built-in functions, and various actions. So one by one action and transformation we'll be discussing in brief with many working example, count by value, count by key, sort by key, zip, union, distinct, joins, different types. And coming to this PySpark SQL data frame, right? Making data structured using map with single expression and data frames and PySpark creating data frame, data frame conversion, PySpark row class, common class, select, collect with column, All these are built-in functions, right? Order by, sort, group by, join, union all, flat map for each simple. And PySpark separate SQL functions, aggregated functions, window functions, date and timestamp functions, JSON functions, read and write JSON files. PySpark built-in functions, right, for performing these various when, expression, lit, split, translate, overlay, to timestamp, to date format, explode, array, collect list, collect set, struct, count, distinct, sum, row number, rank, dense rank, to JSON up. Many functions are there. Many functions. PySpark external sources, working with SQL integration, Spark and Hive integration. Spark with MySQL integration, right? MySQL integration, right? Working with CSV files, JSON files, right? transformations and actions on data frames, narrow and wide transformations, additions of new columns, dropping of columns, renaming columns, adding of new rows, dropping rows, handling nulls, joins, writing data back to external sources, deployment modes, local mode, cluster mode, standalone yarn, Python, PySpark applications, working with stages and tasks, clever executor, building Spark applications, pipelines, deploying, right? Performance tuning mechanism, right? And PySpark streaming concepts and integration with Kafka and machine learning ML practice. So this is what huge syllabus will be discussing, right? Yes.
One question,
Yes.
actually, any will you have any document on PySpark machine learning? Like you are going to cover the machine learning or just only the theoretical concepts?
Not theoretical, some practical part also I'll be discussing, but not all total entire machine learning course won't be discussed here, but some I'll be giving knowledge on all the algorithms. Knowledge I'll be giving algorithms, some implementation of some algorithms, some, right? I'll give you some.
Sure. And also nowadays, even my project, they're using PySpark to run the DAG Airflow. So we're scheduling and running the jobs in AWS environment. So any possible to discuss?
So not that Airflow, but I'll be showing you like how to go with this AWS environment, right? In this PySpark.
Okay.
Okay. So not a worry about this. How to execute this PySpark, the total software, everything I'll be providing you different ways where we can run, and also that how to execute within this Jupyter notebooks, Spider environment, Jupyter, right? Yes. Fine.
Sir,
Yes, yes.
hello. Sir, as you said that Spark is in Spark we can make ETL pipelines. We can can apply transformation logic. So, sir, in Spark and in Azure Databricks, means what is the difference? In Databricks also we can do such thing.
What is that? It's a totally
Azure.
Spark. Yes. Spark
Azure
is
Database.
Spark has got its total. It has got its own execution model, right? It has got its own execution model and has got it has got its own APIs available. Which means we don't need to write a huge coding set. Many APIs are available. Spark core APIs are there. Spark data frame APIs are there where we can perform any operations, right? Simple steps, inbuilt features, inbuilt functionalities we have got, right? You'll be seeing all that. We'll be going through all that APIs one by one, right? Many built-in functionalities of Spark is provided, right? We don't need to write huge codings here, right? It's providing many flexible features. And the main advantage of Spark, right? In-memory computation. But you may ask any other in-memory computations available in the market means yes, available, but they have got some drawback. If you talk about SAP HANA also is a in-memory computation. But as compared with Spark, right? Spark has got many other along with in-memory computations distributed, right? Distributed execution, parallel processes, time, right? All the other features you can see as compared with. In the tomorrow session, I'll be just briefing Spark, how compared with other technologies, right? How Spark, why in Spark only can very high speed processing. And apart from that, Spark data objects and how exactly that processing happening within the Spark level, RTD computations, right? That my discussion will be on that. Right?
I have one more question.
Yes.
Okay. Some applications actually they are using the they are running these PySpark programs, Python jobs in that like Kubernetes cluster instead of the Spark cluster. In Hadoop cluster. Some applications they are running the Hadoop cluster, but some PySpark jobs are already running in the Kubernetes cluster. So what is the difference?
So that's what I'm saying, right? Depending upon, but the Spark, whatever you are learning the Spark APIs, Spark everything, whatever you'll be learning about all the Spark related things, right? Wherever you are running it. But the environment is going to change. But whatever you are learning, the Spark core programming, Spark SQL programming, Spark APIs, Spark ML, Spark streaming, everything, right? You'll be using the Spark related functionalities. But here I'm going to show you on so how Spark is going to run on Hadoop Yarn cluster. So like yes, and how I'm going to show you like in Spark Hadoop Yarn cluster, right? So both the Hadoop and Spark, Hadoop for storage and Yarn, Spark for processing, combinedly both can store huge data and process that, right?
Sure, sure.
Right. Okay. So tomorrow also you can attend the session at 6 p.m. right? Use the same link to connect, right? Tomorrow we'll see more on this, right? How this Spark data objects and the RTDs, right? And the persistence features.
Hello,
Yeah.
sir.
Yes, yes.
I have a
Sir,
question.
is there any prerequisite to go for this course, like learning Python?
So like basic SQL knowledge, basic
Okay.
Python knowledge, basic Linux knowledge.
Linux, okay.
Okay. So anyone, if you are new to the Linux, not a problem. I'll provide some basic Linux videos, commands, basic Linux commands. And the basic Python means just one, like I'll be just briefing you about the syntaxes of Python before I go with the practical part.
Okay.
It's
Mhm. And for this,
basic
like
Python.
whole content wise, the material will be provided like PDFs on the topics which you discussed right now, few minutes back, like those
Yes, yes.
actions, transformations, various those things.
Yes, yes, everything clearly I'll be forwarding you the
Okay, thank you, sir.
no. Notes available.
Hello,
Yes.
sir.
Yes,
Right. Weekend batch or a daily batch?
it's a weekend batch, right?
Only Saturday, Sunday, right?
Saturday, Sunday, right? It will be like 2 to 2.5 hours.
Okay. 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 Sir.
About Vijay, is it how it be for practice purpose? Will you give any software to run?
Yeah, definitely. I'll be providing right different ways. Don't worry about the software. I will be demonstrating about it, how to run out execute things.
Sure.
Sir, video will be provided.
Yeah, you will be getting every session will be recorded. You will be getting the recorded session
Okay.
and the notes you will be getting right both. Okay.
So we will run this Spark session on VMware workstation only, or some other software is required.
So I'll be showing you on VMware workstation where you can, I'll be providing VMware workstation, the software, right? Where you can get all the Hadoop components and the Spark components, Spark and Scala, you can run PySpark, you can run, right? And later I'll be showing you, right, running within this Jupyter Spider IDs, right? How to download, how to execute, and how to use them, right? So you can see that the fees details, other things you can get enrolled by. So you can see a message given by this DurgaSoft online team, right? So it's nearly 7 to 8 weekends batch. So in brief, in depth, we'll be discussing that is the course content, right? It's 7,000 is the fees for it, where you will get class videos, soft copy materials. You can just make a note of the contact details of this online team for any link related things, video related things, and for future reference, right? So not videos will be provided by this online team only, DurgaSoft online team. Notes I'll be forwarding directly to your mails. And the payment process, everything, a big message is given in that, right? Yes, right?
Hi, Vijay.
Yes.
Actually, I am from .NET Technologies. I have 8 years of career gap. Sorry, I need to learn any new technologies to attend these sessions.
These sessions, no, directly you can attend the sessions, everything you can easily understand, right? These are interactive sessions. You can ask queries or doubts anywhere. The only thing is you need to practice, you need to have some. So everything is a practical, nothing theoretical here. Only thing is you need to immediately practice the day itself, asking queries next day, the sessions. You'll be having some time, right? It's a weekend batch. Total week you'll have time to just practice it, and immediately you need to ask queries, anything, right? Related to that. It's not, you can understand this thing. Right.
Actually, I don't have basic idea about Python. Is it okay?
So Python, okay, I'll just show you some syntaxes of Python, and for the people, I'll be just providing you some kind of material for those who doesn't have knowledge on Python, right?
Okay.
There we can buy, because Python statements look like normal English statements. It's not like that much of complex statements like Java, other things, right? You can understand it. Simple syntaxes, you can understand those. So before I go with the practical also, I'll be showing you all this, right? Fundamentals of Python required, right? Fine.
Thank you.
In the weekdays, sir, when we are practicing after the class, right? So at that time, at any point of time, if we struck at that time, then what?
So there will
We
be a
contact-
WhatsApp, there is a WhatsApp group will be there. There is a WhatsApp group. So anytime if you got any error, anybody can take the snap of the error, you can post in the group, right? So anybody can answer it. I'll be answering it, right? Why that error and what you need to do, right? Fine.
Thank you.
So no need to wait up to the next Saturday, right? Yes. So for technical discussions, right? A WhatsApp group. We have a WhatsApp group for the students who got enrolled, right? Fine.
After course completion, do we have any POC? Can we do? I mean, will you
Yes,
give
yes,
any?
I'll be, yeah, I'll be showing you one.
Thank you.
Fine. Okay. So everyone, you can just use the same link for joining tomorrow's session, same 6 o'clock. So regularly we'll be going, the session timings will be right, 5:30 to 7:30. We are starting at 6, but in the coming sessions, right, it will be from 5:30 to 7:30, and in practical, sometimes practicals gets extended, right? Fine.
So tomorrow will be at 6 o'clock.
Tomorrow the timing is at 6 o'clock. Right.
Thank
Fine. So I'm stopping for now. We'll continue tomorrow, right?
Yeah.